In this video, we will be graphing and analyzing this rational function right here. First thing you should do is factor everything you can to see if there's anything that's going to cancel out. So it's pretty obvious that nothing will cancel out because the numerator is just x. So I can probably factor the denominator. X squared is x times x. 2 can only be 1 times 2. And we know that inner plus outer equals middle. Inner, I have 1x. Outer, I have 2x. The middle is -1. So I need a +1 and a -2 to make -1x. So there's my +1, there's my -2. And +1 times -2 is -2. So that works out great. Now, nothing cancels out, so that means there will be no holes. So let's start by breaking that down. So under holes, I'm going to put none because nothing canceled out. What about vertical asymptotes? Well, for vertical asymptotes, you set the denominator equal to 0. So if I set the denominator equal to 0, that means I'm doing x plus 1 times x minus 2 equal to 0, denominator equal to 0. To solve that, I need to set each of the factors equal to 0. That's going to give me x equals -1 and x equals +2. So those are my vertical asymptotes. Let's go ahead and graph these two vertical asymptotes. And there you go. Let's see what's next. So we need the horizontal asymptote if there is one. So remember, horizontal asymptotes are all about the degree of the numerator compared with the denominator. Here the numerator has degree 1, the denominator has degree 2. So when the numerator degree is less, that's when the horizontal asymptote is automatically y equals 0. So y equals 0. Don't just put 0, put y equals 0. Will there be a slant asymptote? Nah. Slant asymptotes only happen when the numerator degree is exactly 1 more than the denominator. So slant asymptote, none. How about x-intercepts? For x-intercepts, you set the numerator equal to 0. So let's see, x-intercepts. We're going to set the numerator equal to 0. So that means we're going to just go x equals 0. So that's it. The x-intercept is always going to be something comma 0. So this tells us that it will be 0 comma 0. Alright, the y-intercept is also going to be 0 comma 0. And I know that because 0 comma 0 is on the y-axis. So let's plot that point. Let's plot the x and y-intercept. Oh wait, I forgot to graph the horizontal. First, let's graph the horizontal asymptote. I wrote down that the horizontal asymptote was y equals 0, but I should have graphed it. Alright, so here's the horizontal asymptote. Alright, so there's our horizontal asymptote. Now here comes our x and y intercept. of 0, comma 0. Alright, so as you can see, this x-intercept is on the y-axis, which makes it the y-intercept as well. Now let's say if you didn't notice that and you were just hunting for the y-intercept. Well, anytime you want the y-intercept, all you have to do is let x equal 0. Alright, let's pursue this. So the y-intercept, let x equal 0. So looking back at the original function, imagine that I put 0 for all the x's. That would give me 0 over 0 squared minus 0 minus 2. But that's just 0 over negative 2, right? Because all these zeros are nothing. 0 divided by anything is 0. So that's why the y-intercept, which is always something comma, the y-intercept is always 0 comma something. And now we have just found out that it's 0 comma 0. You also could have put this in your calculator and done ask x to find the y value of 0. But it's so simple just to plug the value in for the x's on this problem that it's really, why bother with the calculator. So we found the x and the y-intercept. Now before we can do the domain and the range and increasing and decreasing intervals, we need to go ahead and graph the function. Alright, and in order to graph the function, we need to know what x values to put on our little chart. Alright, here's the deal. Every vertical asymptote gives you 4 values that you need to put on your chart. So we have a vertical asymptote here at -1. So let me show you. Let's make a little number line, and we will put -1 right in the middle of it. So using -1, we're going to get 4 values. So if I go 1 unit to the left of -1, that's -2. If I go 1 unit to the right, that's 0. Now in between -2 and -1 is -1.5. In between -1 and 0 is -0.5. So here are 4 values that I need to put on my chart. -2, -1.5. We won't do -1, that's the asymptote, that would just be undefined. But I'll put the rest of these pink values, -0.5 and 0. So we're going to need to do those 4 values. Now we have another vertical asymptote at +2. Okay, so the vertical asymptote at +2 will also give me 4 values that I need to graph. So if I go to the left 1 unit, that's 1. If I go to the right, that's 3. 1, 2, 3. Now if I go halfway in between these two, that's 1.5. If I go halfway between these two, that is 2.5. So here are 4 more values that I need to graph. 1, 1.5, and 2.5, and 3. Alright, so altogether I need these 8 values. 4 values for my first vertical asymptote and 4 values for my second vertical asymptote. So that's how you pick which x values you're going to use. To get the y values, we can use the calculator. So let's use the table feature and just type in the function that we have. So we've got x over x squared minus x minus 2. I'm going to leave it in ask x mode. So I need -2, -1.5, and -0.5. So I get these y values. Okay, so I see -1/2. That's the same thing as -0.5. I see -6/7. That's -0.9. Okay, I see 2/5. That's going to be 0.4. Alright, and I'm just going to keep going evaluating the rest of these. Alright, so these are the values that I got from my calculator. Now I am going to plot these points on my graph. And here's what those points look like graphed. Now these points are plenty enough to show me what the graph is doing inside these asymptotes. So okay, so the graph has to approach the asymptotes on the end, and in the meanwhile they have to pass through these points. So for example, it's got to approach this asymptote, pass through these points, and then approach the other asymptote. So that's going to look like that. Now in the middle, this is a tricky part to graph, but it's got to pass through these points and approach the asymptotes on the end. So it's going to do something like this, alright, where it's approaching the asymptote on the end, it's passing through these points, and then approaching the asymptote again. Notice that the graph does pass through the horizontal asymptote. The horizontal asymptote is not a brick wall the way a vertical asymptote is. The horizontal asymptote shows you the end behavior, but in the middle you can have the function passing through or touching the horizontal asymptote like this. And again, here we're going to approach the asymptotes on the end while passing through these points. Okay, so your function should look something like this when you're done. Alright, and now we are ready to answer the rest of these questions. For example, we can now answer the question about the domain. Alright, so the vertical asymptotes break up the domain. So when I do the domain, I'm looking at the x-axis. Alright, so along the x-axis, this branch goes from here to here. Now this middle branch, does whatever it does, but I'm only looking at the x-axis though, guys. And along the x-axis, this portion of the graph goes from here to here. And then this final portion of the graph goes from here to there. So I have 3 parts to my domain. It goes from -infinity to -1, union -1 to +2, union +2 to infinity. So that's my three-part domain. Okay, now what about the range? Now be careful. There was a problem like this on your last quiz, and almost everybody got it wrong. When you do the range is the y values of a graph. Don't think of it as three separate little ranges. I'm not going to have a range of the left branch, a range for the middle branch, and a range for the right branch. That's not how it works. Alright, it sort of worked that way with vertical asymptotes, but that's not how it works for when you're going in the y direction. We are looking at the entire graph as a whole, and we're asking ourselves what are the y values where the function is present. So I'm going to trace the existence of this graph along the y-axis. So this graph begins down here at negative infinity. Alright, both of these branches of the graph, the lower left and this middle portion, both exist down here at negative infinity. Alright, so the graph goes from negative infinity, and then it goes, the graph still exists here, it still exists. Alright, I get to here, the graph still exists. Alright, now I'm looking at the two parts of the graph that are here to the left and right, and it keeps on going. So the bottom line is this graph exists everywhere. At negative infinity, it's these two pieces. At positive infinity, it's these two pieces. But the graph exists for every y value from negative infinity to positive infinity. Alright, this middle portion of the graph is unbroken. So the graph overall stretches without any gaps from negative infinity to positive infinity. So that's going to be the range, negative infinity to positive infinity. Alright, let's talk about increasing and decreasing intervals. From left to right, this first portion of the graph is decreasing because it goes downhill. So that is a decreasing part of the graph. Now when I go to write down the interval though, I'm only writing x values. So this portion of the graph, where does it exist along the x-axis? It goes from here to here on the x-axis, this portion of the graph in the lower left. That's from negative infinity to negative 1. So that's a decreasing interval. So I have a decreasing interval from negative infinity to negative 1. Now, look at this middle portion of the graph. Alright, the graph, from left to right, the graph goes from being low, and it starts again up here after the vertical asymptote. And it is again decreasing. From left to right is going downhill. So another decreasing portion of the graph. Alright, but don't say positive infinity to negative infinity. That positive infinity is not where this is on the x-axis. Negative infinity, this is not negative infinity. To focus your mind, trace the x-axis. Alright, this middle portion of the graph stays between the vertical asymptotes. It goes from the left vertical asymptote to the right vertical asymptote. So along the x-axis, it goes from here to here. That's negative 1 to 2. So that's my second decreasing interval. is from -1 to 2. Alright, that brings me to the third interval, which is this part of the graph right here. And one more time, from left to right, this is decreasing. So it was decreasing, decreasing again, and decreasing again. But again, I want the x values of this part of the graph, so I'm going to trace the x-axis. Alright, this starts after the vertical asymptote, and it continues to the right forever. So on the x-axis, I would say it goes from here to here. That's 2 to infinity. Alright, so I have one more decreasing interval from 2 to infinity. Alright, that's the entire graph was decreasing. So increasing intervals, there are none. Alright, now let's talk about end behavior. Now, when there is a horizontal asymptote, like y equals 0, the end behavior is easy. A function always approaches the horizontal asymptote on the ends. Please understand that this middle portion of the graph has nothing to do with the end behavior. End behavior describes what happens on the far left and the far right. One more time, the end behavior has nothing to do with what's happening in the middle part of the graph. So, as x approaches -infinity, that means as we go towards the far left, the function approaches the horizontal asymptote. You see, as we go to the left, the function is approaching the horizontal asymptote. It approaches 0. What about the far right? Alright, as we go to the right, the function also approaches the horizontal asymptote. The function approaches 0. So, the end behavior is always going to involve the horizontal asymptote if there is one. On the left side, it'll approach the horizontal asymptote, and on the right side. So since the horizontal asymptote is y equals 0, then for the end behavior, the graph is going to approach 0 on the left and the right. So as you go to the left, the function approaches 0. That's the horizontal asymptote. As you go to the right, the function approaches 0. The function approaches the horizontal asymptote. This will always be the horizontal asymptote if there is one. And that's it for this third graph. I hope this video was helpful. See you next time.